Hey, Rani here. Shall we make a game? And today we are going to try and fix everything we broke yesterday. As you can see, we've gone from our lovely nav mesh to a pile of broken vertices and lines. So we're going to try and fix that. So what we were doing yesterday is we were taking our nav mesh system, which is previously based on triangles, and making it based off arbitrary polygons. And I've got this function here which basically iterates over all of the faces and tries to draw the vertices, but it's not quite working. So we're pretty sure the face count works. Pretty sure the vertex count works. And then we are getting the locations of that particular face. And then we are using that. Yeah, we're basically... Yeah, that should work. That should work. So let's have a look at what we've actually got in this array. Make sure it's correct. It doesn't look correct. It hasn't crashed, which implies we're probably reading from the right area. So maybe we're using the wrong access pattern or something. So vertex location remappings. So we're starting at 0. Oh, I think I see what it is. I need to multiply these by 3. Let me go around to the object to C. Vertex location remappings. Because what's happening here is, what's happening here is that each vertex actually has 3 numbers inside it. It has an X, Y, and Z coordinate. So in the case of a triangle, such as that, we'd actually need to advance 9 positions, not 3. So let's try that. Take a second to build. And that looks healthier. Okay, we've got that working. I'm actually just going to restore the nav mesh triangle I deleted yesterday. Come on, you can do it, Blender. Here, Blender. Thank you, Blender. Oh, I don't think I can. Oh well, I'll just make a new one, I suppose. Yeah, we'll get some real kind of like, stress test scenarios in this where we're making sure that all of our new collision and stuff works correctly. Hopefully this will be useful for many games to come. And this terminal's frozen up. What's this keep happening to me? Okay, let's try again. All right, there we go. Okay. Next step, let's get the normals rendered so that we can tell whether they are facing the correct way. I think they are. Back in navigation mesh. Okay, so we're iterating over the vertices here. So I am actually going to, I'm going to take the center point here and it's going to initialize that to 0, 0, 0. It might be pre-initialized with 0. I don't remember. And then we're going to add every vertex we come to, we're going to add it to that center point. Yeah. And then we're going to divide the whole thing. So we're basically going to take like the mean average. So that should be, I don't think I actually have a, no, I don't have a function for that. Let's add one. Shouldn't take more than a moment. Divides a vector. Divides a vector by a scalar. Vector divide. Scalar divide by. Actually, you know what? I'm not going to do that. The reason I'm not going to do that is it would actually be faster to just do use the what's it called when you do 1 divide by something? It's not called a reciprocal, is it? Maybe it is. I don't know. I guess technically, say go from 7 over 1 to 1 over 7 is technically reciprocal. I don't know if most people would use that in the situation. Anyway, vector multiply by scalar, center 1 divided by 1.0 divided by vertex count. And then we will basically want to make a second vector that's going to be normal end. And we're basically going to multiply scalar. We're going to use the, I need surface normal. Okay, so we have the surface normals. We are then getting pointed to the particular one we need, which is going to be the vertex, sorry, not the vertex, the face, multiplied by 3. And then we're multiplying that by, say, 0.5 to get a nice length at normal end. And then we just need to add so we've now got kind of like a vector pointing in the right direction, but it's pointing from 0, so we just need to add the center point we just calculated, and that will be vector add, there we go, normal end, center 3, normal end. At that point, we then use our static line helper, and we're going to go from white to transparent. And center. Okay, that should draw a white line from the center of each. Did I change a header file? Oh, I guess I did. Oh, damn it. Hey, I'm okay, thanks. You alright? Just trying to fix everything I broke yesterday. Okay, those normals look... Wait, those ones don't look right. Let me just double check here. Oh no, that might be right. That might be right, because it is kind of pointing right slightly, and that is pointing right slightly. Don't worry, my head hurts. I'm the one you should probably know. Okay, so the next thing we need to do is we need to draw the kind of like the edge exit normals. So that's basically the directions pointing out of each polygon, showing which direction you have to be going in to cross over into the next polygon if you're kind of like moving over the map. So we first of all need to calculate the edge midpoint. So again, that's going to be the mean average of the first and second points. So just gonna add them together. So previous vertex location, next vertex location, and 3 axes and edge midpoint. And then multiply by scalar. So that's basically a mean average of the 2 points on the line. And then I need to exit normal end. So basically I need to do something very similar to this, where I basically multiply the exit normal by by a length, which will give us kind of like a normal out, and then add it to the edge midpoint, which will give us kind of like the end of that line. Exit normal end, edge midpoint, and then draw it. Now at the moment I'm using the wrong normal, but this should draw a normal out the middle of each line. What color are we going to make this? Let's make it yellow. We haven't had a yellow yet. Okay, see how that looks? That's not right. We've got an infinitely tiny point, so that's not right. Oh, I I drew it from the edge midpoint to the edge midpoint. That occupies a single pixel, doesn't it? Ah. Okay, there we go. So now we've got lines, but they're, oh, sorry. They're not currently facing in the right direction as they're basically using the same normal as the center lines. So I need to go fetch the proper, hang on, exit normal. That's the one. Exit normals. And then when I'm in a face, I get the face exit normals. And then, there it is. How you doing this morning? You good? Oh, it didn't like that. Oh, is it still called? Is it still called something else? Oh, it's still called edge exit normals. Fine. Okay, come on. Let's see those yellow lines. That's not quite right. They're meant to be kind of like facing out of the, I wonder if I've got the same bug. So it's gonna be the bit where it writes the exit normals. It's gonna be the bit where, it's gonna be the bit where it writes the remappings and exit normal remappings. I think I have to multiply that by 3 because there's 3 axes in 3D space. And nope, that's just definitely wrong. Okay. All right, so look in here and see if we can figure out what's going on. So got our exit normals, and so we basically have like a list of all of, we have these normal vectors which are meant to kind of like point in the direction you have to cross the edge of a navmesh tile to get into the next one. And I've got just basically a big heap of numbers, and then I've got this sort of like mapping table that says, for example, this is where you find the exit normals for the first polygon, second, third, fourth, whatever. So I think I had that wrong, but it still doesn't look right. So it's possible my code to calculate these is wrong. Let's have a bit of a look. So it should be the first, hang on, 1, 2, 3, 4, fourth, because I think this is our first polygon. It was last time. Unless deleting and re-adding it has reordered it, it might have done. Let's have a bit of a look at the data, see if we can figure out what's going on. So 27, why would it be 27? I think that might have already been correct, I think. I don't, oh yeah, I'm already multiplying by 3 there, so that's fine. So that was correct previously. Okay, so have a look at the data and see if we can figure out what's going on here. So we should delete all polygons but 1, just to get an idea, just so you can have like an isolated case and see if we can figure out from the data what's going on here. Okay, now we have 1 polygon, and those are definitely wrong. Those are definitely not right. Can't quite figure out what they're actually doing. So let's have a look at the data. Where are exit normal? So they are. So, what do they look like? Well, they don't look like anything like what we can see in the in Engine, because that one's pointing along, primarily along positive Z, which would be towards us. That one's pointing to the right, that one's pointing away from us, and that one's pointing to the left. And it kind of looks like they're all just pointing, I don't know where, they're pointing somewhere. So I think it's more likely that the rendering code for it is wrong. So we seem to have the right edge point, the right, we seem to have the right midpoints. It's just the normal we're applying to it's a bit wrong. So getting the exit normals for the face, multiplying the face by 3 to find... it's the vertex we should multiply by 3, not the face. Right, yeah, so it's just using the wrong number. So it was using the polygon number, not the edge number, to select the... So that looks right. That's actually giving us kind of like a direction out of the polygon in each direction. Let's put the other polygons back in and see how it looks. Okay, come on, build, please. There we go. So yeah, we've now got these nice kind of like completely opposing normals. So it'll be the same, you know, you've got this invisible kind of plane extending from this line upwards. You have to cross to get from this one to this one and vice versa. Next up, we have the kind of like normals that are in each corner and they kind of poke out like this. And that's so that when you're crossing both this face and this face, we know exactly the line that you're basically kind of sitting on. So, I called these something really stupid and I always have to look at, there we go, edge, exit, intersection, normals. I have to look that up every time because it's such a damn stupid name. It's just completely not memorable. Right. Very, very, very similar, just grabbing the face version of that, using the face number we have. And then we're going to use the vertex as the start point. I think it's the previous one we're using though. Previous vertex location, we've got that. And what's it called again? It's called an exit intersection normal. Terrible name. I don't know why I use that name. It's just completely not memorable at all. I'm gonna make it a different color. Let's make it magenta. Okay, let's have a look. See what we get at the other end. Now I think those are right. I think they are. So basically, yeah, that's basically like if you are over this edge and you are over this edge, you would basically end up on this line extending up into space. Okay, so that looks like it's working. I think. Yeah. It is actually kind of right that they're not kind of, you know, occupying the same space on the corner like this because this face and this face actually influence the line slightly. Okay, next thing I need to do is I need to get the collision back in. Oh, I've got this function to find the closest thing actually. That also needs doing. Right. Yeah, I've got this function here to kind of like, given a point in 3D space and a nav mesh triangle, it basically finds the, well, not quite the closest point on it, but it kind of clamps it to the kind of volume of the nav mesh triangle. And that needs basically rewriting to, you know, allow it to have multiple edges. Well, more than 3, that is. 3 is multiple, but... Okay. Constrains a point to the volume of a navigation mesh face. Okay. Sorry. We need to adjust this very slightly. We need to... previously, there was kind of like just a struct that had all the information about a triangle in it, but there's so many things now that I've actually split them out into separate kind of lists for kind of like... just it's not like caching a bunch of memory that isn't relevant when you're, say, like searching for a good route. So yeah, I need to make it so that like you give it a mesh and you give it the index of the polygon that you're on. And it's not a polygon, it's called a face. It's called a face. Damn it, I keep calling them polygons, they're called faces. Okay, navigation mesh constrain to face volume. Navigation mesh triangle, navigation mesh triangle. Yeah, I need to change that. Oh damn it, I'm writing everything in the wrong order this morning. What am I doing? Ah! Okay, and then we just need to pass in the index that we're using, which is called face. Okay, that's our new set of kind of parameters for this. Now I did write some really handy code for this that would kind of like, really cleanly demonstrate what it was doing, but I've since deleted it, which wasn't very smart. Okay, so currently this this horrendous mountain of code that took me hours and hours and hours to write, it basically like it's mostly copy paste. Cause it's like checking like it's built specifically for triangles. It's checking like the first, second, and third edges. So I'm going to throw that, and we're going to loop instead. So let's see what it needs. So it gets the coordinates, it gets the surface normal, which is actually quite important. So I'm going to grab that out. And yeah, it grabs the vertices. Okay, yeah, okay, we can grab all the stuff on kind of like a face level. So if I go up here to this, yeah, this kind of thing. Okay, right. Okay, so we need to fetch the number of faces, and I think that's, yeah, it's a vertex count. Okay. Oh, it's just called count. Okay. I forgot about that. Okay. Okay, so we've got our vertices. Next up, we need to get the vertex locations, which I think are floats, and they're read-only. So it's going to be, hang on, vertex locations is the navigation mesh. Vertex locations based on the face, and we need the surface normal. And we're going to need the edge exit normals. Yep, that's what they're called. I'm going to remove the word edge from them later on though, because I just think it's too wordy. I'm trying to reduce how wordy a lot of this code is, because I've got some ridiculous stuff for like variable names are like 50 characters long. It's way too much. And we've got edge exit normals, and we've got intersection normals. There we go. Exit intersection normals. Oh, that's such a terrible term. I really should come up with a better one. Okay. So now we have a look at this. What this actually kind of did, it wasn't actually written as a loop, but it basically was one, is it checked whether, let me get Sprite up and kind of like draw what this is doing, because it's good for my own reference too. If you've got a triangle like this, right, and you've got a point here that you want to lock onto this, you basically check whether it's over that edge. And if it is, you kind of lock it to the surface. Now, something that's just occurred to me is that the kind of thing that makes it slightly rough is that, if I just extend these out, is that you can have a point here, right, which is actually inside this line, right? But when you actually project it onto this line, it actually ends up then over this line. Yeah, basically like correcting it on one edge makes it incorrect on another. So basically you then have to check the kind of like neighboring edges, and if it's over either of them, you then have to snap it to the corner. Not ideal, but it can be done. So I need to, I need to then basically loop over all the edges and do that distance check. And if it then fails, the distance check, if it's like over the edge, I then need to compare against the sides, either side of it. Okay. Why is this complaining? What's it on about? Ah, I know why. Right. So our next step is we need to get the location of this vertex and then do our kind of comparison. So okay, we've got our location. We then calculate the distance between, hang on, if I just draw this up again. Calculate the distance between our point and one of the vertices on the edge. So, yep, it's like that. And subtract the point. So subtract the location of the vertex from the point, which gets us the difference between them. We then distance over. We then perform a dot product, which gives us with the edge normal and this. Okay, that's good. And different, and our exit normal, 3 axes. Okay, got it. So, was I using any kind of tolerance in this, or is yeah, it's just checking to 0. Okay, right. So if we're over that edge, that's when things are going to get complicated. Otherwise, if we don't ever find ourselves, I just need to put a note in here, checking its surface. Otherwise, we just copy the, we just copy the point to the result as we didn't find any changes to make. Okay, that's good, that's good. So if the distance over is over north, we then need to check the previous face, which we don't need a second difference for, because like the previous edge, the one we'll be checking here, shares a vertex, so we can actually use that same vertex and difference. Yeah, trying to think how this works. We can also use that for the surface check. So, okay, distance over is over 0.0. We need to get the previous exit normal. Oh, sorry. Now, if we're crossing over the first, if we're on the first vertex, we actually have to wrap all the way around to the last, because like if this was like, you know, edge 0, we don't want to get -1. It doesn't exist. We want to get 1, 2. We want to get 2. So if we have a vertex, it's going to be vertex take 1. Otherwise, it's going to be the vertices take 1. So actually, we can kind of like micro-optimize that slightly and do that. Yeah, that feels like an optimization. In fact, I think might be able to do that. Yeah, that's incomprehensible. I like that. So now we can get the distance over the previous just by doing this. And if the previous distance over is 0.0, to do. That's when we use that kind of, that's when we use this kind of pink, hang on, mouse cursor stopped working. That's when we use this sort of pink normal. We're basically at that point over two edges and we need to use that to kind of project into that line. Otherwise, oh, and in all these cases we need to return if we do any of this. Otherwise, to do check next, to do check surface. The annoying thing is that if we're over the previous, we could be under the surface, and again, like if we're over the next, we could be under the surface. If we go under the surface, we could actually end up then, as a result of snapping back to the surface, we could actually end up exiting the polygon through another edge, which is just so annoying. Like geometry, why do you gotta do this to me? Okay, think, concentrate, think. Sunday mornings. Okay. Right. So we're now over the previous vertex, so now we have to do a dot product. We need to get the exit intersection normal. Yep. Okay. Yep. That's the one. Okay. I might actually keep a reference to the previous vertex. Actually, that'd be kind of handy. And then just update it every loop. Yeah, that actually means we don't have to do that kind of bit of horrible logic maths every time we need to get the previous index. Distance to surface is going to be the dot of the difference and the exit intersection normal. Took me a moment there. And it's a dot product, it's not a dedicated function for that. Okay, so at that point, the only thing that we need to do now is we need to clamp it. So we need to make sure that, we're not going through zero, we're not going through the surface. And we need to multiply the distance to the surface by the normal, by this kind of like purple sort of edge normal, and then add it to the location of the vertex, and that should snap us to that line. So, hang on, I'm thinking, and it does hurt. Come on, multiplied normal. That'll do. Okay, vector by scalar, and we are multiplying the exit intersection normal by the distance of the surface, and we're going to clamp it so it can't go below zero, because that would mean we go under the surface. And what else are we going to do? Normal, add that to, hang on. The previous vertex location. Oh, hang on a second. Hang on a second. Hang on, I am thinking. Yeah, it's definitely the vertex location. Okay, right. And then we're writing that to the result, and that should do it. That should be correct. Okay. Right. Okay, I'm just thinking. Yeah, that's good. That's fine. So next up, so we've dealt with the case we're going back once. Next, we need to deal with the case we're going forward one. So just going to put a index in here for the next one. Maybe this would be better with modulo, actually. Next vertex is the vertex add 1 modulo the number of vertices. Yeah, that'll do. I'm sure the compiler will come up with something smarter than that. It usually does. Right, so next we need to get the next vertex location. That's right. Next vertex, and hang on a second. Do we though? Yes, we do. Oh no. Okay. And then we need to get the next exit normal. Next vertex multiplied by 3. Exit normal. And then we're going to overwrite this difference with the place we basically ended up putting the point. Oh, it's just occurred to me, I've made a mistake here. I've made a mistake. I need to actually project this point onto the yeah, I need to actually do this. I actually need to project this onto the surface. I never actually did that. Okay, so let's move this multiplied normal thing further up. We're going to be using it a lot. Oh, come on. Come on. Think. I've made many mistakes. This entire code base is honestly a mistake. Oh my god, my brain is dead. Right, it's the exit normal multiplied by how far over we are. It's got 3 axes, and then we're putting that multiplied normal, and then we're going to subtract that from the point to get us the point projected onto the plane. And then we're calculating the difference again. So now we're in a new location. Okay, I'm not using point anywhere else, that's good. All right, okay. That's about, I think that's right. Okay, so at this point, we know we're not over the previous line, so we're going to check if we're over the next line. So, yeah, we're comparing the point that we have with the next vertex location. It didn't like that for a second, and that made me worried, because that wouldn't make a lot of sense if it didn't like that. And then we're figuring out how far over we are over that edge. It's probably a much faster way of doing this. There probably is. Okay. So if we're over that edge, then we do something very similar to this, except we're using the next exit intersection normal. Next vertex, and hang on here, exit intersection normal, distance to surface. Yeah, I think that's right. I think that's right. It looks right. It looks right anyway. Okay, so next up, we need to, at this point, we know we're over, let me just draw this from a different angle. We've got a triangle. We've got kind of like a sort of like, you know, infinite kind of like wall extending into space. We know we're over this wall, and we've kind of projected the points back onto this wall. But if, say, the wall was particularly kind of, you know, if it was leaning like this, it might mean that putting it back over the wall actually placed it below the surface. So we need to detect that and snap it to this edge. And the way we're going to do that is, oh, thinking about it, I should be comparing, oh. Okay, I'm just going to swap the ordering here and hopefully not break anything in the process. The reason I'm going to do that is we already have because I want the distance to the first vertex, not the second, because I have these kind of like edge sort of coefficients that face from there to there. Okay. So we project it onto our point, we've then calculated the difference, and we have a surface normal. So let's get the distance to the surface. So if the distance to the surface is less than 0, at that point we know we're under the surface, and that's when we project it along this edge. And we can clamp it to just either end. So we know that we're not crossing over into, say, like, this or this space. Whew. This is a lot of numbers for like 10 AM on a Sunday. Okay. So we know we're below the surface. So now we're going to get the distance along it. Yeah. And we're going to do a dot product between the difference and the edge coefficient. I think they're called edge coefficients. I think they are. And we've got 3 axes. So now we know that number is basically 0 if you're at this vertex and 1 if you're at this vertex. And all we then need to do is do a linear interpolation. So that's from our vertex to the next vertex. And we're using the progress along, which we're going to clamp between 0 and 1, so it can't like fly off the ends. And then it has 3 axes, and we're writing that to the result. That should do it for that. Do I actually have like a... Oh, hang on. Next vertex location, we need that. So let's grab that and put this, say, up here, so we're going to be needing it. And let's also spell it correctly, that helps too. Okay, so now that we've checked every case where we're crossing an edge first of all. So next up we need to check the case of, well, what if you're under this, what if we come in here and you're not over any of the like walls into the neighboring sort of triangles or polygons, but you're under the surface. In which case we need to basically do what we've done here, and we need to sort of project you onto the surface, and then we need to check that it didn't cross the edges. And we can probably get, I think I might have done in here, let's have a look. And yeah, I'm doing the same thing pretty much, where I kind of like I just project you onto these edges if you're over them. Okay. All right, so we've looped over those. We need to get the, we can use any of these vertices to kind of get the distance to the surface. So I'm just going to move this difference thing all the way out of here because we're actually using it a lot. And I think there's a, no, it's not. Okay, right. So distance to surface. Yep, is the dot product of the surface normal and the difference. Now I'm going to calculate the difference. I'm not currently calculating it. Where's the difference calculated? Where is it? There it is. Now we can do something a bit cheeky here, and we can actually use the... hang on a second. I'm thinking, and yes, it does hurt. We can actually use... What was I going to say? We can just use the vertex locations list because that's actually just a pointer to the first item in the list. So using that is the same as pointing to the first thing in the list. So we've got the distance to the surface, and if it's less than, if we're underneath the surface, we do stuff. Otherwise, we just go, the point you've given me is already inside the volume. I don't need to do anything, just copy the input to the output. Okay. So next up, we need to do the thing up here where we multiply the surface normal by the distance underneath it and then subtract it, I think. Hang on, I'm thinking. Yeah, that's right. And this multiplied normal, where's that defined? Because we're using that quite a bit as well. I'm just going to move it up here with this. I'm glad I did all the kind of like difficult work with this first, actually figuring out how the heck to build this thing. Because let me just focus on the building the thing. Okay, so we've now projected that point onto the surface, and we now need to check whether we need to loop over these again and figure out whether it's over any of these edges. Oh, hang on, I've just spotted something, I think. Oh no, that's right, that's good. Okay. So we're going to reinitialize this previous vertex with, oh, actually we're not using the previous vertex, we can just drop that entirely. And delete most of this out. So yeah, we're going to be taking we're going to calculate a new difference here. So we've now got the difference between, oh no, we need to calculate one for each vertex. Okay. Yeah, so we've projected that point onto here, and we're now checking, is it over any of these edges? What? That's not what I've resu isn't defined. I'm like, it doesn't say resu. Okay, so we now have the point relative to the exit normal. We now know if it's over. If it is, we then use that, we use this. So again, we get the progress along this edge using this dot product. And then we need to know the next vertex location. So we actually need to know that in one case though. So I'm going to put that down here. Where's next vertex location? Where are you? Where are you hiding? There you are. Good, good. Okay, right. Let's press make and see what happens. That might work, it might not. Who the heck knows? Did I change a header file again? I think I did. Anyway, how am I going to test this? How am I going to test this? How am I going to test this? Guess what I could do is I could add some sort of hacky test code in here and just have it kind of like pick a point in 3D space and kind of like draw a line between. Yeah, okay, that's going to work exactly the same for the moment. But if I, the likelihood of this working is like 10 to 1 first time. I'm just going to delete all polygons except kind of like an example, kind of like an exemplar one. So let's do that and do a build. Okay, we're down to 1 polygon, nice and simple. And now I add just a random number in here, pretty much. So I get the, oops, sorry. Let's get the rough center of this. Okay, yeah, we're going to basically just make a point in 3D space. We're going to use some like trig to make it kind of like, you know, spin over it and just sweep it in all sorts of interesting ways. And we're going to calculate an endpoint, which is going to be using the that one's not going to be constant. We're basically going to use that constrain. Yeah, so we're going to give it the navigation mesh. We're going to give it the face that we're currently on. Give it the start point, give it the end point that we want. And then we're just going to tell this to draw a line between the two. Right, and what colors are we going for? We're going for, I think we haven't had blue yet, so let's use that. Just double check what colors haven't we had. I kind of used most of the spectrum, haven't we, at this point? Let's just go for green, why not? Okay. Next thing we need to do is we need to make this count the number of layerings. I did definitely just, yeah, it's right there. I'm like, I did definitely make a variable for that, right? And I did, and it just, for whatever reason, just Visual Studio Code just doesn't see it. Thank you. Okay, so now just use a bit of good old-fashioned trigonometry. But in a way that you never see someone actually use it in a classroom. And that should make kind of like a point kind of spin around that polygon and draw a line showing us where it kind of placed the closest point. Let's have a look. Well, it's drawing us a line, but it doesn't seem to be moving. Why isn't it moving? We're definitely incrementing it, right? Definitely incrementing that number. Why isn't it moving? That's weird. It should be doing like kind of like a spirally thing, but it's just doing nothing. What am I doing wrong here? Let's try setting it to a just try setting it to a known value that should do something different. That's kind of weird. What's going on here? Oh, wait. I calculate these positions. I'm not actually using them. There we go. That's why it's not moving. It's basically using the face normal. Okay, that looks like it might be working. I'm going to slow it down like a lot, just so I can get an idea of, I can watch it a bit more closely and see if it's doing anything stupid. So, kind of like, as soon as it exits the polygon through the bottom, it starts projecting onto the bottom. That's nice. That was a bit weird. Whatever it just did then didn't look right. That kind of projected onto the wrong side. That was a bit weird. Okay, so it's not quite right, but it's pretty close. So let's just restart this and see how far into it we have to get before it does something strange. You know what? I could actually use a browser feature here. I could actually use the oh, it's not called what I think it is in here, is it? Press start recording. Oh, I thought this was going to look like timelines in Chrome. I guess it doesn't. Okay, fair. So what it probably comes down to is one of these branches in here is probably wrong. It's probably wrong somewhere in here. Not quite sure which branch is wrong though. So what I'm going to do is I'm basically going to see if I can get it to start at the point at which it's doing something a bit weird. So let's just see how long we have to go in before it does something weird. So that's right. I think that's right. That was wrong there, whatever that was. So that was about. Should get rid of this code that kind of like advances it. Where is it? Where is it? Where's it gone? And I'm going to fix this to say 20 frames in. Actually, it's going to be way more than 20 because we're running at 60 frames a second. So it's going to be about 10 seconds in. Okay, a bit more than that, I think. Let's go to say 900 frames. And if I can get this to consistently stick somewhere wrong, that doesn't look quite right, but it might be. One of the things that can get quite confusing is that if you look at like the shape of the geometry and the camera's kind of here, you can get a point like under the surface, so here, and it looks like it should be. It looks like it should be over one of these edges, but it's actually under the surface, and that can get quite confusing. Let's instead initialize it at say 800 and see if we can spot. See if we can really dial in exactly where it does that weird kind of flip. Well, that was weird. What's that? Let's skip to say 1200. See if let's try and narrow down this exact spot at which it does something completely wrong. Okay, overshot slightly. Let's try 1100 because at that point, I can basically put code in to make it throw an error. It's going to be between the two. Okay, 1150. I can basically make I can put code in every branch of that thing and make it crash and tell me exactly which branch it's in when it's doing something wrong. So yeah, that's wrong. That's the point at which we need to check it. So constraint to the face volume. Do I have the error header? Yes, I do. I just remember to remove that when I'm done. So IE error A, B. I'm just going to look in the console and see which of these it hits, if any. E. E, F, and G. I doubt it's going to be G because that should produce the same output as the input. Okay. That crashed the game. Let's see what it came up with. B. Okay. Let's have a look at this then. So I'm just going to comment all this back out. Oops. Okay, so it's this. This is wrong. Oh, I spelled multiplied wrong. That's probably, well, that's not going to make any difference, but let's fix that while we're here. Okay, so something about this isn't right. So how did we get to here? So this is where we're over an edge. And we're above the surface. And so let's just draw this up. So we've got a triangle. We are over this edge, but we're not beneath the surface. And we're now checking whether we're over this edge. So we should be able to use the same vertex. Should be able to. So we're calculating a new difference here. Yes, we are. That's good. We've got the previous vertex, which should be right. Yep, that should be right. And then we're checking the previous distance over. Okay, so Yeah, we're getting the previous sort of edge exit normal. We're comparing it to the difference, which is with a vertex that shares that edge. If we're over that edge, we're then getting the the exit intersection normal, which is kind of like the line up there. We're then doing a dot product between that and that, and we're getting the distance to the surface. Hang on a second, that doesn't make any sense. Hang on a second. Let me just build this. The reason that doesn't make any sense to me, if I just comment and say it, the reason that doesn't make any sense to me is, isn't it landing like in the middle of a line? Yeah, why would it be? Oh wait, it's not. It's actually ending up on that edge. Right, I thought it was like tracing along this line. It's actually going up here. Okay, that's actually correct. Okay, so yeah, what's going on there? Because that's definitely not over that edge. So next thing I'm going to check is which vertex is this over? Now, if I had a proper debugger, I would be able to, you know, stop and inspect, but I don't. So I'm going to have to do a bit of trial and error. So I suspect it might be vertex 1. My suspicion was wrong. Okay, is it vertex 0? It is. Oh, hang on. Hang on a second. Hang on a second. I think I might see what the problem is here. I think I might be using the wrong, let me just clean this up. So, I'm over this edge, right? And I'm comparing to this vertex, right? And I've established that I'm over this. Okay, so yeah, I've got the right exit intersection normal. Okay. Next up, let's check that we've got the correct previous. Oh no. So the previous vertex in this case, given it's got 4 sides, should be 3. Let's just double check that. Let's make sure that's right. Yeah, okay, we've got that right. So we're definitely looking at the right thing. Okay. Why isn't this working? Why is this doing silly things? What is it trying to accomplish? Let me just check in the where's the movie theater code? There it is. So we've got our vertices, we've got the first one, second one. I'm just gonna mark these up. And I'm gonna have a look in Blender and see which order these are in. So I can see straight away it's the ones on the right that are coming first. So no, so that one's closer. So it's actually going in the order 1, 2, 3, 4. Well, or not 1, 2, 3. So it seems to think for some reason that it's over this edge when it's. Let me just comment out the debugging code and build it. When it's pretty evident that there's basically no way that point is over that edge. There is just no way that's even physically possible. Okay, so why is it, so it's actually all the way up here the issue we're having. Now, we're pretty confident the exit normals are right because we're visualizing them and they look right in the visualization. Is there anything different about how we're visualizing them versus how we're using them? So, face exit normals, vertex multiplied by 3, and I think that's exactly what we're doing down here. Exit normal multiplied by 3. Okay. Well, that should be working then, shouldn't it? Why isn't this working? Why does this think why does this think it's over that edge when it's clearly not? Why would that point appear over that edge? Now, unfortunately, I don't really have any way of debugging this. I don't really have any way of getting the information out that I need. How do I solve this? Ah! How do I solve this? Ah! Hang on. I am thinking. Oh, hang on a second. No, I was just thinking maybe it was actually over this edge and seeing its previous, but it's not. It's... Ah! Why broken? Why broken? Because that should be... Oh, there. If I'm just going to look at the exit normals as well, make sure they're kind of correct. That's weird. Hang on a second. We've got the two vertices on the right-hand side, right? And they're definitely... Let's just double check the coordinates here. They're definitely the coordinates on the right-hand side. That's 2, 1. Oh, it's running from there to there. Ah, okay. It still makes no sense that it thinks it's over that edge, but I thought it was running from the back to the front. It's actually running from the front to the back. Okay. So why does it think a point all the way over here is over this? Let's... Why does it think that? So I can kind of understand why it would think why it's over the near edge, why it's over this edge, but not why it'd be over this edge. Oh my god, brain engage! Brain! Why would it think that? Okay, so we've got that point in 3D space, right? And that's definitely correct. We're subtracting it from the vertex location. That's definitely correct. We're getting a difference. We're getting our exit normal, and then we're dot producting them together. And that should give us the distance over that edge. Why would that not give us the distance over the edge? Unless this exit normal is incorrect. Which I don't think it is. Looks right to me. Oh my god. What you're witnessing right now is a slow, just complete breakdown of just my understanding of basic maths. Okay, so... Okay, there is a way I can write some text to the screen. It's kind of awkward and roundabout, but I think I'm going to have to do it to... I think I'm going to have to do it to figure out what the heck's going on here. I need to see what the real numbers are. I do have a font rendering system that's kind of, yeah. Let's put this in the to-do bracket down here. And I think it's called small. Yeah. Again, it's not really meant to be used like this, but I'm just really struggling to figure out what the heck is going on in here. So, sorry, it's I font, right? And we use a small font, and I think I've got a thing in here to write a number. Yes, I do. Oh, but it only writes whole numbers. Sorry, it doesn't write fractional numbers. Damn it. I never implemented writing like floats and stuff. So I guess what I'm going to do is I'm going to multiply it by a big number just so I can see what the heck's going on. Okay. And then I'm going to layer that. I keep writing front. I'm going to layer that onto the screen. So and using the left alignment, top left corner of the screen. I just make it white, and I'm also going to have to include the video buffer in here. I don't currently have it, I don't think. My God, losing my mind trying to figure this out. Okay, this should print to the screen exactly how far over it is. Oh wait, I didn't do a reset. Yeah, it's a stateful font system, so it actually you kind of push characters onto a stack and then draw them, which means if you don't reset afterwards, the stack will actually just continue to fill with numbers. Okay, so it thinks it's 0. Wait, what? No, that is right. That is right. Okay. All right. Okay. It actually will as well, yeah. I think I've only allowed for like a few hundred characters in there. But it's more the fact that every frame, it would just keep adding the text to the text in the previous frame. Like up to 2048 characters on the screen. Otherwise, it just blows its top. Okay. So we're going to write the 3 axes. We're going to write a bit of text in between. What other functions do I have in here? I've got write that one. Write single byte. Okay, I probably want that one. And I think I can just pass it just arbitrary text. It should, yeah, there we go. And then I can do the same with this. This is assuming, by the way, this font rendering system doesn't break, because this font rendering system is pretty jank. It barely functions, in fact. So we've got difference, difference, difference. Okay, that gave us some numbers to play with. Okay, so let's see here. The exit normal is the first one. So it thinks the exit normal of this is kind of forward. What? Hang on. Yeah, it thinks, hang on, it thinks the exit normal of this line is pointing towards the camera. Why does it think that? That's not right. Okay, let's have another look at this movie theater code. What's it actually put in here? I know it has grabbed the first one. Hang on a second. Hang on a second. So our first edge is from the right-hand side, near to far, right? And then our first normal is for some reason pointing towards the camera. How is that possible? Because it's also drawing correctly here. Hang on, I'm now very confused. I'm I'm extremely confused now because we've got another part of this code that's using the exact same data and it looks different. Face exit normals, face vertex multiplied by 3, and the exit normals are the edge exit normals. Okay. Edge exit normals. It looks like it should be coming in from that one instead. Because then, yeah, this list looks like it's offset by 1. I'm very confused. Hang on, let me just close this file just in case I accidentally edited it or something. I'm extremely confused now. I'm like, that doesn't make any sense to me at all. So yeah, from the right-hand side, we're starting close and then we're going far. So we are here, here, and then left-hand side, far. Yeah, so we're basically going counterclockwise from the bottom right corner. Okay. And then we've got the exit normals, which should be AB. But it's not. It's actually for this for some reason. Ah! What's even happening? Is it possible? Hang on. No, it is. Right, okay, okay. It's actually a bug. It's actually a shared bug between the export code, like the code that actually exports the model into. Basically, I've got some code that like reads in the OBJ file and turns it into C code we can then use, and I've got this code which puts it on the screen, and they both have complementary bugs. So one of them corrects for the bug of the other one. So the issue is that I'm using the previous vertex location, not the next. Right? So that means that it's drawing the kind of like the surface normal. It's meant to be here. Sorry, it's meant to be here, here. And I'm guessing the exact opposite bug must exist in the exporter. So we actually want the next vertex location. I can see how I got to this point, but it's still wrong. So we'll take the vertex, add 1, and then we're going to modulo it by the vertex count. Just wrap it around back to 0 if it reaches the end. And that should fix the issue, I think. Well, it'll this should make the issue apparent on screen. My God, what a stupid bug. Yeah, so you can see now these are all kind of like pointing at strange angles because these are actually the normals that this code is using to try and figure out if it's crossed one of these edges. Okay, I'm actually kind of glad I wrote this out because I would not have been able to figure this out otherwise. Okay, so next up we need to have a look at the code that actually generates that normal and try and figure out where it went wrong. And I think I know where it went wrong. So I think I've got a bit in here that takes like the previous vertex. Yeah, there it is. Face exit, face face edge exit normal. And I basically need to get rid of this previous vertex entirely. It just shouldn't be here. It should instead be, instead of being next vertex, it should be just vertex. And instead of being previous vertex, it should be next vertex. Get rid of that. It was an attempt at optimization in code that like runs in like milliseconds anyway. Why do I do these things to myself? Plus edge index plus 1, and we're going to modulo it by the face length. Okay, let's see what that does. Come on, you can do it. All right, that's now sticking to the corner, which is actually what we want. Right, so I am next up just going to check something else. If I do this, let's actually just make it a bit more kind of like obviously kind of like tented like that to the camera. That should I'm not sure that's worked. As you can see, these two normals are actually kind of like pointing in different directions now, which is because they should be kind of completely kind of well, not complementary, but sort of pointing away from one another. So these two faces should be seeing each other. So there should be a bit in here where it finds the neighboring. Here it is. Oh my god, do we have the same bug in the bit of code that actually works out which neighbor? Okay, let's see if we can find all instances of the word previous in here, because I've definitely done it wrong. All right, okay. Man, this micro optimization in here has cost me so much headache and time. All instances of the word previous are now suspect. Every single one of them. You get out of here. Yes, this is basically code that it basically because we have like a big sort of pile of polygons, and we're trying to figure out which ones are neighbors of which. And it looks like this has the same sort of off by one bug where it's kind of like it's looking at the wrong edges between the two. Hang on, thinking about this. Is this actually right? No, it should be the next one. Oh my god, such a huge waste of time this has been. Plus 1 modulo by the face length. And I'm going to change that from previous just to sort of current. Where are we here? Where are we here? Okay, we're outside of the code we're looking at, so that's fine. All instances of the word previous, all code, including the word previous, is now suspect, as we've had multiple bugs come from it. Yeah, get rid of that. Wait, was that used anywhere? Okay, it was there. Okay. Right. Let's run make, and let's see what happens. That might fix the bugs. It might do, it probably won't, but we can check. Oh, it didn't like something. A navigation mesh face is degenerate. Okay. Hang on a second. Right, what it actually means by degenerate is it's got two vertices in the same location, because you can't really have an edge between... Oh god, edging, we're not making this any better, are we? You can't have an edge between two vertices that perfectly overlap. I'm making this any better. Okay. Where's this coming from? That's fine. Hang on. Thinking, ow. It should be first index, not next first index. Okay, there we go. Okay, is that gonna work? Oh, it seems to be building. That's good news. Okay, all right, so now we have these kind of like, these are definitely sharing kind of like, yeah, they're definitely sort of neighbors because they're in opposite directions. That's good. I'm not sure this has worked. That doesn't look like it's worked, because like one of these edges is kind of like, you know, straight and parallel, and the other one isn't. Right. Okay. I cannot wait until this nav mesh functionality is done and I can just put it down and do something way more interesting, because this is just driving me insane in a way that isn't interesting. Okay, so intersections. This is where we're writing the intersection, and what are we doing here? What are we doing? Maybe this one should have been using... Okay, so let's think about this. So we have a triangle. Okay. And let's say that for sake of argument, it's 0, 1, and 2. That's a 2, by the way. Let's say we're at 1 over here, and we're trying to calculate which way up this is. So the way we do that is we take this direction, and we take this direction, and we find a direction that's perpendicular to both. So that one should be using the previous, shouldn't be using the next. Damn it. So this was like the one place it was actually valid to do that. Okay. Previous edge index is going to be the face length minus 1. And then at the bottom we're going to previous edge index is going to be the edge index. We can get rid of this, don't need this anymore. Right, I think that might be where the confusion came from, because I think I might have written that code pretty early on and then basically replicated it elsewhere. So again, now we have these lining up nicely, and we have these lining up nicely, so that should be correct. So now we can just take the other face back out. I'm going to put this back to where it was. And I'm going to re-export that. And then, hang on, thinking, ow, don't think too hard, it hurts. I can get rid of this code now, so I'm pretty confident that works. And get rid of all this. And we can go back to just sweeping over and making sure that it looks like it's correct. It's, you know, correctly picking a point inside the volume. Okay, that still doesn't look quite right, but that looks way closer than it was. Yeah, why did it jump all the way over there then? That looked like a bug. But that's getting closer. That is so much closer than it was before. And that was a bit weird. Okay, that's really close to working now. We've probably got just one or two edge cases just to sort out. I think I know what's happening. I think it might be the same bug where it's actually looking at the wrong kind of, the wrong corner. Let me see here. How do I prove this? It's going to be the edge intersection normal. How often do we use these? Okay, so if we're crossing over into the previous one, it's going. Let me just draw this up on here. So we've got this, and we're checking. We've crossed this face here, and then we realised that we're also crossing this face. So we need to check this. So this would have been edge, say 1. This would be edge 0. We need to check it against exit. Hang on, exit intersection normal 1, not 0. Oh my god, it actually is edge guarding, you're right. Okay. So that looks right. That looks right. Maybe it's the surface code. Okay, all right. So I'm just going to try and narrow the stack because I'm pretty sure it's supposed to do with the corners. I'm going to try and I don't think it's this code, but I'm just going to try and roll it out. Yeah, what was it doing there? Because it kind of, hang on, it kind of jumped to that corner very strangely in a way that doesn't quite make any sense. Ah! Again, let's see if we can get it to kind of like, that sort of spot from the very beginning. Okay, so let's jump forward, say 2 seconds, and see if we're in the right spot. So that'd be 120 frames. So let's go to 270. Yeah, there we go. Yeah, it's almost like it's... What is that doing? That doesn't look right at all. Wait, did... Oh, I have to push it forward another 50 frames. Okay. Because at that point, I can pause it and have a really good look at what it's doing. It's kind of... Because that looks like it might be plausible. I'm not entirely sure. I think it might be inside the... What is that doing? Yeah, because it's doing this really weird thing where it kind of traces around the corner in a way that looks really strange. I think that might be underneath the surface at that point. Okay, let's try commenting out the code for under the surface checks again. Man, I really hope this is worth it. So if it's... Okay, so yeah, that little sort of like curvy bit at the end, that's the under the surface check. That's fine. So yeah, it's something about the kind of like first edge checks that are the real issue here. Okay, so what we can do is we can just comment some of this code out and see what it does. Or rather, copy the input point to the output point and see if the issue still reproduces after that. Okay, that's one of the bits that doesn't look right. Kind of sorted out. Okay, well, we've figured out roughly where it's happening anyway. So we have the progress along. We're going from the vertex location to the next vertex location. Okay. And the difference is to the vertex location. Okay. So that should be kind of right. Ah, hang on a second. I think I might know what the issue is. Might be the same bug we were just experiencing, except for it's for the edge coefficients. So I don't visualize those because for start off, they're kind of like, not planar, but kind of like in line with the lines. So you wouldn't be able to see them. But also they're just, the way they're calculated is a real hack. The way they're used is just like it's a real terrible math hack. Oh, hang on. Am I multiplying by 3 in here? Yes, I am. Okay, that's fine. Let's have a look at this then. So go over the faces, that's fair enough. Go over the edges, that's fair enough. Okay, and then we get the vertex location and we get the next vertex location. That's fair enough. We then work out the difference between them. And hang on, what are we doing here? I'm trying to remember. Well, that's the face edge. That's the face exit. We don't want that. We want the edge coefficients. Ah, here's the edge coefficient. So that should be fine, I think, because it's getting the yeah, it's getting the position of the it's getting the position of the vertex we're starting from. So basically, what an edge coefficient actually is, right, is that if you have like if you have this vertex here, and the end of the edge is here, and you have like a point here, it's basically a special vector where if you do the dot product between that vector and the edge coefficient, it actually gets you a number where 0 is that vertex and 1 is that vertex, without having to do any additional like division and stuff. Which means it's kind of like a normal vector and it points along the edge, but it's actually the inverse length of the edge. So if this edge was like 5, it'd be 0.2. So it kind of it kind of inverts the length of the edge. It's very strange. Doesn't make a lot of sense, but it seems to work. That looks right. Right, why isn't this working? Why isn't this working? Yeah, that's the whole code for it. It's really simple. It's basically normalizing, but then sort of dividing by the length squared rather than the length. And then we're writing the remappings, which are really simple. They're basically just coefficients. Yep, that's simple enough. That should be working. Why isn't that working? So I guess the next thing I can do, I can have a look at the data and see if I can figure out what the heck is going on here. How many polygons do we have right now? We only have the one. Okay, that's correct. So it's still a matter of we're still going close right, far left, close left. So coefficient looks kind of right. Yeah, that looks right to me. Why isn't this working? Ah! Okay, next thing I can actually try is comment that out, and I can just hard code a value in here and see what it does. Because it should. That's interesting. Oh, there you go. Right. Yeah, it's basically planting the kind of point right in the middle of the line. So that's actually correct. So that the value, the actual edge coefficient is correct. It's just something about how we're calculating. So the linear interpolation is correct. It's the actual edge coefficient that might be wrong. Damn it. Okay. So we know that it looks vaguely correct because it's going to negative, which means it's sort of right. Let me just check this is what I used to do with it, because it could be I used to do something different with it. No, it looks right. Okay, next thing I'm going to try is, if I come into here and I go into my, see the edge length, I'm going to try something. I'm just going to verify this concept even works. I'm just going to make this edge like exactly kind of like 1 unit long. Because it's entirely possible this entire concept I've had is completely wrong. Yeah, that I can't skip a I can't skip storing the length. No, that's still acting weird. Okay, let's put this back the way it was. Export again. So it looks like it's off by 1. So I am, just for the sake of argument, going to add 1 to that and see what happens. Okay, I'm going to subtract 1 from that and see what happens. Okay, that looks kind of right. I mean, that looks kind of wrong, but that looks less wrong. Okay, I'm going to put it to do there. Y minus 1. Because I have absolutely no idea why that fixes the problem, or at least seems to. And it doesn't seem to work on that edge. Oh my god, why isn't this working? Okay, let's open this file back up and have another look at these edge coefficients. So they still look kind of right to me. Yeah, that's going towards the back, that's going towards the left, that's going towards the front, and that's going towards the right. I am just going to, hang on, export from this again, just so it doesn't overbuild. And just so it undoes any changes I had kind of in here. So coefficient remappings is 0, that's good. It's going towards the back, it's going towards the left, it's going towards the front, it's going towards the right. Ah, why isn't this working? So I guess the next question is, what's it actually doing sort of there? So I'm guessing that's above the surface and it's dropped below the surface there. Oh, hang on a second. Yeah, I might have to stop in a second because I'm getting nowhere with this. I'm just getting more confused. So yeah, actually, I think I am going to stop there. Thank you very much for suffering through this with me. I was hoping to get this fixed today, but I guess not. Have a great Sunday.